Hello, welcome back. So in this video I would like to show you something about arrays. Okay, so we have seen some example of an array that we use. An array is pretty much a group of data that has the same type, so we just create an array to use. Now array can be returned in the method too. So I want to show you sorting a list. Okay, sorting list. So we can use an array to sort a list of number. Okay, and I'm going to show you, we're going to create a package this time. Okay, so a package is pretty much, what is a package? A package is just telling a path or location where you save your file. Sometimes you can right click and create package right there. Okay, so for example, this is my path. Okay, if I browse this, you see location of my Java project under sorting list folder under source. Now if I want to create a package, I pretty much just create a subfolder inside the source folder pretty much, and we like to name something relevant to the topic. Sometimes we like to get with the education, okay, like organization name, NBCC, and then CSC 200. Okay, and sorting. So that can be a subfolder's name edu, and another subfolder name NBCC, and another subfolder name CSC 200, and another subfolder name sorting. Now in your program, when you right click create new class, when you click, it's going to add the statement package right there. Okay, and let's say sorting number. So I'm going to put the main here, and you see a package statement should pop up right there. Okay, so pretty much just you see that this time when I create a class is happening to be in that package. Like before, we did not create any package, so it's going to be default package. Like sample of overload here, no package name. For this time I have a package. Now in this video I want to focus on using an array, return an array in a method. Okay, use it in a method and we can return it back. Array can be parameters of your methods. So let me start to create a method step. Okay, I'm going to say this method name sort. Okay, sorted list. So I'm going to pass in an array of number. Okay, I'm going to name it an array of integers. Okay, an array of list. Okay, which is a number list. And after I pass into sorted list, this should return an int array back. So that's how we declare the type of an array that is going to return an array of integers. So normally I will just say, okay, return number, we just do int like that. But now we just put the brackets to say, hey, it's going to return an array at this point. And I'm going to, since I'm using the main here statics, I'm going to create the statics method for this, and we learn what is the statics. Now it's supposed to return, okay, I'm just naming a list. Okay, so list start to say list pretty much just after you sort it in the array. Okay, so at this point I'm going to say list that is going to return. So you're going to get the number of lists in and you start to sort this. Okay, now this has to be a type. Okay, an array of list, and return the list back. Now we need to implement the program to do that. So let me create the attributes or the class variables name and integers, and this is a list. Okay, equals to, now we start to, let me rename it a little bit slightly the difference. Okay, so say num list. Okay, and I can initialize my arrays in the curly braces like that. Okay, so it's an int, so I just say 5, 3, 8, 4, 2, 9, 0. So this is an unsorted list. Okay, so this is the, let me just say unsorted list. Okay, the number with unsorted list, and we should be able to initialize. Okay, this is an array, so we need to put a brackets. Okay, square brackets, and initialize value directly to the array. Array start at index 0, right? 1, 2, 3, 4, 5, 6, 7. So it's going to be 0 to 7, but the size of array is 8. Now what I want to do is I want to pass this list inside the main. We know we have the list of unsorted list number. So I'm going to pass to the sorted list. So I pass the unsorted list number. So my sorted list is supposed to sort the list for me. And after I sorted the list, I'm going to print out, okay, the sorted list. Okay. Now since let me just create a list inside the main. Okay. I'm not going to create as a class variables. Alright, so we have the list. Okay, and the list is going to get sorted. Now, let's look at the concept here. I pass in an array of unsorted list. This is an array to the methods named sorted list that I'm going to create here. And the method is supposed to implement the sort version and then return the array of the sorted list back. Alright, now let's take a look at how do we do this. So to sort the list of number, if you look at this number, we have to compare the first index to the second index. And if we see the first is smaller than the second, then we need to pretty much swap, right? Swap mean 3, 5, right? And the remaining is going to be the same because we only compared the first two. So that's the first time I have to sort. And then you may look at same thing, the number that you try to compare, which is 5. You start to use it to compare to the next number. If it is smaller, we're not going to swap. So we stay the same as 3, 5, and 8. Now the same list again here that is not sorted yet. You can start to compare the same number 5 to 4. Okay, so if you see it's smaller, you just swap between these two locations, which you could get 3, 4, 8, and then 5, and then 2, 9, 0, 1, right? Now, again, this is going to repeating over and over. Okay, so we still use number 5 as the key to compare to the next one. Where this is smaller, we can swap. Right, in this case, we can swap. So we can see it start to do repeating over and over again, and 5 and 9 will swap. Right, and then we need a loop to help you start to see that. Okay, so if I manually type this in, so we will say 2, 9, and then we have to swap, right? Because we see that 2 swap 0, right, and 5. We see 0 is smaller, same 5 and 1. We start to see that we need to swap these two numbers again, right? So we have 1, 5. Okay, so if you start over again, we pretty much just start from 3, and then 3 compares to 4, and we start to swap again. So if you keep doing this, right, the key concept is we want to move the smallest number to the left, okay, and the highest number more to the right location, and the highest go to the most right, the smallest go to the most left. So we need to find a way that we can sort the number. Okay, now this algorithm is not easy, so and after we get the algorithms done, we have to translate into code, Java code here. So now let's start looking at the list. We see that our list is not sorted yet. You see why we compare, we just keep comparing 5 to the next number and just move the smaller than 5 to the left. And there are many ways to do the sorting. This type of sorting still give you in like an order, which move the 5 from the left to the right. So how are we going to handle this? So there are many ways. Like I said, let's look at a sample smaller list. I'm going to give you like 3, 4, and 5, 3 numbers. So this is sorted. So now if I say 4, 3, 5. So first I want to compare 4, right, to 3, and we see that 4 is greater than 3, then we do swap. So we have 3, 4, and 5, but again we still need to compare, right, 3 to 5. So that means we start to use index, right? We said this is an index 0, right? This is an array, index 1 and index 2. Array has index, so we always compare the first index to the next, and the next, and to the last index. If it is smaller, we swap, right? Like I said, if I can add more numbers, it could be 1. So if we start to compare, right, index 0 to 1, we said, hey, we have to swap because 3 is less than 4. And then we use the same index 0, we start to compare to 5. Okay, so we see smaller already, then we don't swap. And now we start again to index between index 0 and 3. 3, 4, we found that 3 is smaller. No, 1 is smaller, so we swap. So we get 1 and same for 5 because we just swap 3. Now we merge that with index 0. We reach the goal that the smallest number is going to the left. As you compare from the previous algorithms, we never get to a chance to move the smallest number to the left. So now we just need to move to the second index, which is index 1, and we no longer need to compare index 0 to anyone because we know it's going to be sorted. So this is like a loop that we're reducing by 1, okay? And then we start to compare index 1 to index 2. If it's smaller, we swap. No, if index 2 is smaller than index 1, then we swap. So now it's greater, we don't do anything. And then we compare number 4, which is at index 1, to number 3 at index 3. And we found that, hey, 3 is smaller than 4, and we start to swap. And we start to see that our list is in order afterward. But actually, you still have to compare 2 to 3, and we found a smaller than is the sorted list, finally. Alright, so we can use this with this unsorted list, these algorithms that we just created, okay? So, how do we do this? We said we need to use the loop to help to for, right? Int I equal to 0, I less than the number list, okay, dot length. So if it's less than, then what we try to say it's going to increase by 1, right? Because we compare index 0 to the n, okay? So now we want to say if right list, which is the number list, right, that we pass in at index I, which is we starting from 0, okay? So if it's happen to be what greater than, right, the next list that we want to compare, okay? So we need to compare index 0 to the next index, and we have to do increment index every time to the n, right? So we can use another loop then, okay? So let's say int j, and we actually start j from 1. There's no reason to start on the same location 0. We compare I to pretty much the next one from the list to j. So now we said if it is okay bigger, then we pass swap. So we call swap function, which we could pass index, okay, of I and j, and then we going to pass the list that we want to swap to. Okay, so now we didn't have that method created, we need to create methods, and this is called swap methods. So swap, we said, okay, we get the number list at index I, we might just move it into the temporary, okay, storage, become temp. And then we start to say we need to swap, that means number list I equals to the location number of list j. So that we want to do, we pretty much doing swap. Now I've been replacing by j, but we store the value of I, of index I, into a temp, then we can just move temp back to j. So that's how we swap. So whenever we see the number, right, smaller index has a greater number, then we swap. Otherwise we stay the same, and we compare to the next one, which is j, okay, and j square loop and q pretty much the same, right, to the end of the length. and then we just do increment J, okay, for the next round that we want to search. So after that, we say we sort this, okay, with which we use to loop, or we call nested loop. If we found the number on the left is greater, then we do swap. Otherwise, we make it stay the same. Now we may see that we loop to compare I to J, okay, and then we have to increment, right, the outer loop, which is 1, and compare again to the list. Now this one should give you a sorted list already, right? So after this loop, we should get a sorted list, okay, which we can just return the sorted list, which is the number list, back after we sort. Alright, so let's see what we get here. Okay, so it's written in number, which is an address of the array number list. Now I need to loop and print this out. I can't just print like that. So we have to do a loop int, okay. So array we can also do for each, like now after we sort, we need to print it out. So for an array name, okay, so I'm going to pretty much just, after we sort it, I'm going to create an added int array, okay, that was named sorted list, okay, let's just return from the array name sorted list. So for, okay, int I equals to 0, so print from beginning I less than the sorted list dot length. So we go print it all I plus plus. So I didn't show you for each. We can use for each too. Now we're going to print out the sorted list and ordering by I here. So alright, so first line we pretty much be able to move 0, okay? You see 0 is just go to the first location because that's the smallest. Like I said, this is just the first line that you compare. Now you need to do the second round, okay? So pretty much just compare now 9 to the next number, right? Let's check. We move 0 to the left. So actually this is also do the sorting too, but you can see this is 1, 2, 3, 4, 5, 8, 9, right? It's almost sorted here, right? But it's just in different orders in the descending order, and 0 actually has to go to the bottom. So now we have to check this algorithm and see what is wrong. And this is pretty much going to be your class exercise that I want you to fix this problem, revise the logic and fix this to make it sorted list and unsorted list. And thank you for watching.